Welcome to DriverDTrains. Thanks for stopping by. I'm your host, DriverD. We're joined again today by our conductor and brakeman, Scratchy-C. In August 2023, I released the first video in my series on assembling a DCC-EX command station to control our trains. A lot has changed in the intervening 2 years for both the command station hardware and the DCC-EX software. In December 2024, DCC-EX announced the release of the EX-CSB1 Express, an all-in-one plug-and-play command station and booster. This marked a major milestone in the evolution of DCC-EX from an Arduino-based project to a product that runs on a variety of modern microcontrollers. Recently, I completed a new series of videos on DCC-EX in 2025, featuring the EX-CSB1 Express and more. We learned how to configure our DCC-EX command station using EX-Installer and the Arduino IDE, and add new functions to the command station using the myhal.cpp sketch. We learned how to customize the display on our command station, added a second display to the command station, and then learned how to add additional displays using I2C multiplexers. Finally, we looked at 2 DIY alternatives to the EX-CSB1. In order to assist both new and returning viewers, I have compiled all the videos from the series into a 2-part Supercut, so you can have the complete set all together in 2 videos. In this video, Part 1, we'll look at the EX-CSB1, learn how to configure a DCC-EX command station using EX-Installer and the Arduino IDE, and look at 2 DIY alternatives to the EX-CSB1. In Part 2 of the Supercut, we'll look at how to add and customize displays on our DCC-EX command station. The resulting video is quite long. To assist with navigation through the various parts, I have included a table of contents at the beginning of the video, as well as individual chapter markers in the bottom left corner of the screen. Be sure to check this video's description for links to the original videos in the series, as well as to community posts with all the websites, products, and code from the videos. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. An idling locomotive moves no freight, so let's get this train rolling. DCC-EX in 2025, EX-CSB1 and more. Supercut. Here are all our train orders for today. Part 1. DCC-EX in 2025, EX-CSB1 Express. Introducing the EX-CSB1. In December 2024, DCC-EX officially announced the release of their EX-CSB1 Express, an all-in-one plug-and-play command station and booster. The DCC-EX team had been developing the EX-CSB1 over the past year with design support from their Austrian manufacturing partner Semify, which had also designed the EX Motor Shield 8874. A few popular YouTube channels got a sneak peek at the CSB1 ahead of its release.
I have been keeping a bit of a secret over the past few months. My new layout has been running on a new ready-to-go out-of-the-box DCC system, and it's the most affordable DCC system that you don't have to build yourself.
The EX-CSB1 includes all the parts of a DCC-EX command station, including an ESP32 microcontroller, 5-amp EX motor shield, Wi-Fi, and an 8-line OLED display, all in one small package. The form factor of the EX-CSB1 Express is basically identical to that of the EX Motor Shield 8874, which is itself designed around the form factor of the Arduino Uno. In other words, for a DCC command station, this thing is tiny. A single 12 to 25 volt external DC power supply provides power for both the EX-CSB1 and the tracks. The EX-CSB1 can also be connected to a computer for programming and testing, or to JMRI via a USB serial port on the board. The brains of the EX-CSB1 is an ESP32 Room32E microcontroller with built-in Wi-Fi and antenna. While the chip also includes Bluetooth, DCC-EX is not normally configured for Bluetooth, as the ESP32's Bluetooth interferes with its Wi-Fi, and I have not yet seen confirmation that the EX-CSB1 specifically supports Bluetooth. The EX-CSB1, like all of DCC-EX, is an open source project. We can find all the files and hardware designs for the EX-CSB1 on the DCC-EX GitHub page, including all the Gerber files and bill of materials we'll need to order one from a PCB manufacturer such as JLC PCB. However, what viewers will probably be most excited about is that we can order the EX-CSB1 fully assembled and ready to run from any of a number of resellers worldwide. In the US, we can order the EX-CSB1 directly from the DCC-EX online store, starting at $120 plus shipping. A 15-volt, 5-amp power supply suitable for most model railroad scales adds an additional $25. If the DCC-EX store does not have power supplies in stock, you can find a similar power supply on Amazon for about the same price. I'll include a link in this video's description. The EX-CSB1 does not come with a case, unless your reseller provides one, but ships with a sturdy plastic mounting plate that can be screwed in place to our benchwork. Downloadable STL files for a 3D printable case are also available on Thingiverse. Connecting the EX-CSB1 to our layouts. We also need to connect the EX-CSB1 to our model railroad. The connections are the same as those on the EX Motor Shield 8874. There are two pairs of screw terminals, an A pair and a B pair, for two independently controlled motor outputs. The terminals feature removable plugs that make it easier to attach our wiring to the connectors. By default, the A terminals will power the main track, while the B terminals will power our programming track, but we can change that. Note that the A and B terminals on the EX-CSB1 are arranged opposite to those on the standard Arduino Motor Shield, with the B terminals for the programming track on the EX-CSB1 being located adjacent to the input jack for the power supply, while the A terminals for the main track are further from the jack for the power supply. One thing to watch out for when handling the EX-CSB1 is the ESP32's Wi-Fi antenna, which extends off the side of the board and out the side of the case. I'm not sure how fragile it is, and I don't really want to find out. To connect the EX-CSB1 to our model railroad, we need to wire up two pairs of wires from the command station to our tracks, one pair for the main track and one pair for the programming track. To make the connections between the command station and track easier, I recommend using screw terminal barrel connectors, male and female, in the 5.5mm by 2.1mm size, as they are easier to plug and unplug and more durable than the connectors on the EX-CSB1 itself. For wire, the screw terminals will accept wire from 16 to 28 gauge. We can use either solid core or stranded wire, but remember that stranded wire is thicker than solid core wire of the same gauge, so 18 gauge stranded wire will be about as heavy as we can go. If we use stranded wire, we will also need to take a few steps to make sure we get a good connection with the screw terminals on the connectors, as they tend to spread the wire strands, which eventually causes them to come loose and break. We can try tinning the wire with a bit of solder, but if our tinning increases the diameter of the wires, they may not fit in the connectors. I highly recommend using ferrules with stranded wire for screw-type connections. There are ferrules made specifically for crimping the ends of stranded wire. One of the advantages of these ferrules is that they funnel all the strands of the wire into a smaller diameter than we could do otherwise, without having loose strands hanging out. A special crimping tool makes a square post suitable for use with screw terminals and spring connections. Nip the ends to get the length just right. Insert them carefully and tighten the screws. Snug as a bug in a rug. I'll include a link to the tool I use in this video's description. Of course, this is not an issue with solid core wire. At the other end, we connect our wires to the existing track wiring on our layout. We can also solder our wires to a pair of rail joiners or other track feeder wires, either for the layout or an improvised connection to a programming track or a bit of track on the workbench. Using the EX-CSB1 to control our trains. As with any other DCC-EX system, we control the EX-CSB1 and run our trains using an app such as Y-Throttle or Engine Driver on a smartphone or tablet. We can also control the EX-CSB1 with JMRI, either through a USB cable connected to our computer or over Wi-Fi. And there are commercially available throttles, such as the train control systems TCS, UWT50, and 100 that can connect to DCC-EX over Wi-Fi. Be sure to check out some of my previous videos on how to use Y-Throttle and Engine Driver with DCC-EX or JMRI. As I mentioned, the EX-CSB1 is an all-in-one plug-and-play command station and booster. To use it as a command station, we simply take it out of the box, plug it in, and connect our phone or tablet to its Wi-Fi access point using the password shown on the OLED display. Be sure to bring your readers because the display is pretty tiny. We'll look at how to configure the EX-CSB1 to connect to our home Wi-Fi in the next video. Then, in our Y-Throttle or Engine Driver app, we select the DCC-EX server, enter the DCC address for our locomotive, switch to the throttle screen, and we're off. It's that simple. All aboard! The EX-CSB1 can also run DC locomotives and serve as a booster for another command station, but those are conversations for another day. Right now, let's go run some trains. Part 2. Configure DCC-EX EX-CSB1 with EX-Installer. The DCC-EX EX-CSB1 is a fully assembled plug-and-play command station and booster that comes pre-installed with the latest version of the DCC-EX EX command station software, which means that all we have to do to use it is take it out of the box, plug it in, and connect it to the tracks on our layout, and we'll be ready to run some trains. However, we may want to connect the EX-CSB1 to our home Wi-Fi for easier access, or add EX-Rail automation scripts to the EX-CSB1, like those we developed together in my recent series on automating trains using DCC-EX EX-Rail. And eventually, we are going to want to update the DCC-EX EX command station software to a newer version. Let's look at how to do those things using the DCC-EX EX installer. Install the EX installer. The first thing we will need to do is install the EX installer. We can find a link to the EX installer on the DCC-EX homepage. This installation process is different for Mac and PC users. We'll quickly touch on the Windows process first, then we'll look at the Mac process. There are two versions of the Windows installer depending on whether our computer has a 64-bit architecture or a 32-bit architecture. Almost all computers made in the past 20 years have a 64-bit architecture. There is a button for an automated installer that will detect our computer's architecture and select the correct version of the installer to install EX installer. Whew! That's a mouthful. After we select the correct installer, or let the automated installer do it for us, we will find the Windows EX installer file in our Downloads folder. We'll drag the file onto our desktop and create a new My EX Installer folder to put it into. I do not recommend leaving the installer in our Downloads folder because DCC-EX will update the installer from time to time, which means that we may end up with multiple copies in our Downloads folder, which could lead to confusion. Also, we will want a folder in which to store our configuration files, so let's just create one now. We'll leave it here on the desktop for the moment. We can file it in an appropriate place later. Now we can run the EX installer. The first time we run it, Windows Defender may flag it as being an unrecognized app. If it does, we can click More Info and then tell it to Run Anyway, and the EX installer application will launch. Windows users are now ready to use the EX installer to configure the EX-CSB1. Let's look at how to install the EX installer on a Mac. From the DCC-EX homepage, we'll again select the link for the EX installer, and this time download the Mac version of EX installer. This will download the EX installer to our Downloads folder. Again, we'll drag it to the desktop and put it in a new My EX installer folder that we'll create. Again, I do not recommend leaving the installer in our Downloads folder. This is even more important for Mac users because we are about to use the terminal command line to modify the EX installer, and if we have more than one version of the installer in our Downloads folder, we won't know which version we are editing. So we'll place it in a My EX installer folder on our desktop for now and find a nice home for it later. The first thing we want to do is give our Mac permission to open the file. If we try to double-click on the icon, we will see a message that the file cannot be opened because it is from an unidentified developer. So instead, we will control-click on the icon by holding down the Control key, which is the key on the bottom left corner of the keyboard just to the left of the Option key, and clicking on the icon. We can also right-click the icon by using the right button on our mouse, if it has one, to accomplish the same thing. This will bring up a pop-up menu. We'll select Open from the top of the menu. Our Mac will again warn us and ask us if we're sure we want to open the file. We'll click Open. This will open the file in TextEdit. We will immediately quit TextEdit without making any changes. Now, we'll open the Mac terminal. Terminal is the Unix-style command line interface that the Mac inherited in OS X 10.0 after Steve Jobs returned to Apple in the late 90s. The Terminal app is located in the Utilities folder inside the Applications folder. The easiest way to launch Terminal is to hold down the Command key and press the spacebar to bring up a spotlight search. Then we can just type the first few letters in Terminal until we see it listed in the box, then press Return. This will open the Terminal command line interface to the computer. In the Terminal, we will type the following, but do not hit Return just yet. CHMOD space plus X space. Be sure to include both the space before the plus sign and the space after the X. Then we will drag the installer file we just opened in TextEdit from our My EX installer folder into the terminal window. We then select the terminal window and hit Return. We should see the icon for the file change in the My EX installer folder, and if we look at the file's information, we will see that it is now a Unix executable file. We can now double-click on the icon to launch the EX installer application. Note that the EX installer actually runs inside the terminal, so there will also be a terminal window open when we run the EX installer. We can hide it so that it is out of the way. Mac users are now ready to use the EX installer to configure the EX-CSB1. Configure DCC-EX EX-CSB1. For the rest of this video, I will demonstrate using the EX installer on a Mac. However, everything is the same for Windows. First, let's make sure that we are using at least version 0.0.20 of the EX installer. Earlier versions won't recognize the EX-CSB1. Ask me how I know. Once we confirm the version number, we can click the Manage Arduino CLI button. Now we need to install the Arduino Command Line Interface, or CLI. We'll click the Install Arduino CLI button. This will take a while. We also need to check the slider for the Espressif ESP32 in the Enable Extra Platforms box. This will take another while. Now, we need to connect the EX-CSB1 to our computer with a USB cable. We need to make sure that we are using a proper USB-C cable that supports data transfer and not just a charging cable. USB cables should have the USB symbol on them and charging cables shouldn't, but that is not guaranteed to be the case. We should also plug the cable directly into a USB port on our computer rather than a USB hub, at least until we make sure that everything works. We can try using a hub later if we want. Once we've connected the EX-CSB1 to our computer, we'll click the Select Your Device button on the EX installer screen. The installer will start looking for USB devices connected to our computer. If we have multiple devices connected, it may be difficult to identify which is the EX-CSB1. We can either try unplugging our other devices or unplug the EX-CSB1 and then press the Refresh Device List button to identify which port the EX-CSB1 is connected to. Once we identify which port is the EX-CSB1, we can click the radio button for that port and then select DCC-EX EX-CSB1 from the Device drop-down menu. We can verify that the EX installer is connected to the EX-CSB1 by clicking the View Device Monitor button and typing open angle bracket equals close angle bracket in the Enter command box and then pressing Return. We should see a response on the display that track A is configured as the main track and track B is configured as the programming track, unless for some reason you've changed it. Now we can close the monitor window and press the Select Product to Install button. Then we click the large button for the DCC-EX EX Command Station software. We can now select which version of EX Command Station we wish to install and whether we want to configure a new command station or use an existing configuration. For now, we'll create a new configuration. So we'll make sure the Configure Options on the next screen button is pressed, and then click the Configure EX Command Station button. Now we can tell EX Installer about our command station. We'll start by toggling on the option for the display. The EX-CSB1 has a 132 by 64 OLED display. Then, if we like, we can select the option to start with the track power on. We can also have EX Installer create a myautomation.h sketch for us for our EX Rail automations. Be sure to see my just completed video series on automating trains with DCC-EX EX Rail. We can toggle the Advanced Config option while we're at it. That will give us a chance to review our settings before we upload them. We'll want to select the EX-CSB1 as our motor driver, unless we've added a second EX motor shield to the stack. Now, we can configure our Wi-Fi options. To connect our EX-CSB1 to our home Wi-Fi network, we select that radio button, then enter our network name and password. We can keep the default host name as DCC-EX, but if we think we are going to use the EX-CSB1 on a network with other DCC-EX command stations, we might want to add an additional identifier so that we know which command station we are connecting to when the time comes. Now, if we click the Advanced Config button, we will have a chance to review and conceivably edit our config and My Automation files. If everything looks correct, we can click the Compile and Load button and then Load. EX Installer will compile the code and upload it to the EX-CSB1. This will take another good long while. Unfortunately, EX Installer does not update us about the status of its progress, so we'll just have to trust it and wait. When EX Installer is done, a screen will show Congratulations! We can now back up our config files to the My EX Installer folder on our desktop that we created earlier. With that, we can close EX Installer, and Mac users can quit the terminal application. We have now completed configuring the EX-CSB1. Upload existing configuration to EX-CSB1 with EX Installer. Now let's take a look at how to upload our existing configuration to the EX-CSB1. We'll again launch the EX Installer from the My EX Installer folder where we placed it. Then select our device and the DCC-EX EX command station as the product to install. Now we select the Use My Existing Configuration Files radio button and then click the Browse button to navigate to the My EX Installer folder we created on our desktop or wherever we may have placed it. We can select any of the files within the folder and click Open, or double-click the file, and EX Installer will scan the folder for our various configuration files. Now, when we click on the Advanced Config button, we'll see tabs for all of our configuration files listed across the top of the text window, including our config.h file, all our EX-Rail automation files, and any other configuration files that we might have, such as a MyHal hardware file for a second external LCD or OLED display. We can even edit these files in the window. We can then compile and then load our existing configuration to the EX-CSB1. If we made any changes to our configuration files, we'll want to be sure to back them up again. EX Installer will ask us if we want to overwrite our existing files. If we want to keep both versions, we should browse to another location or create a new folder on our computer. When we're done, we can close EX Installer and Mac users can quit the terminal application. Locating the EX Command Station sketch. If for any reason we want to look at or copy the EX Command Station sketch, we can find it in our Home User folder, in a folder called EX Installer, not to be confused with the My EX Installer folder we created on our desktop. Inside the EX Installer folder, in our User folder, we will see the Command Station EX folder. This contains all the pieces of the DCC-EX EX Command Station software. Every time we install a new version of DCC-EX, the EX Installer will overwrite this folder, but we can make a backup copy if we want. This would be especially useful if we make any edits to the sketch code. But if we're going to do that, we should probably use something other than EX Installer. We'll look at that option in the next video. But for now, let's go run some trains. Part 3. Configure DCC-EX EX-CSB1 with Arduino IDE. In my last video, we learned how to configure the DCC-EX EX-CSB1 using the DCC-EX EX Installer. Now let's take a look at how to do that using the Arduino IDE. Here are all our train orders for today's route. First, we'll download and install the Arduino IDE. Then we'll launch the Arduino IDE and use the board manager to add support for ESP32 microcontrollers to the IDE. After that, we'll download or copy the EX Command Station software and copy any existing configuration files we have into our Documents folder. Then we'll connect the EX-CSB1 to our computer and upload our newly configured EX Command Station code to the EX-CSB1. Finally, we'll look at how we can customize the EX Command Station code using the Arduino IDE and try an example for ourselves. Sound the horn because it's time to leave the station. Configure DCC-EX EX-CSB1 with Arduino IDE. Download and install the Arduino IDE. We can download the Arduino IDE from the Arduino website. Remember that the Arduino website address is arduino.cc, not .com. Then we'll select the Software tab at the top of the page. Next, we choose what type of computer we're using in the Download Options box. We will be asked if we want to contribute or just download the software. We'll click Just Download for now. Finally, we'll be asked if we want to subscribe to the Arduino newsletter. Again, we'll click the Just Download button. The Arduino IDE will now be downloaded to our computer. We'll find the file we downloaded in our Downloads folder. On the Mac, this will be a disk image. We'll double-click to open the disk image. We can then drag the icon for the IDE app on top of the alias to our Applications folder, and our computer will copy the file. We can then close and eject the disk image. Windows users will find the IDE installer in their Downloads folder. We'll double-click on the installer, agree to the terms, and click Next, and then Install, and the installer will install the IDE in our User Programs folder. When the installer is done, we can click Finish, and it will launch the Arduino IDE. We will also find a shortcut to the IDE on our desktop. Add support for ESP32 to the Arduino IDE. Next, we'll add support for the ESP32 to the Arduino IDE. The DCC-EX EX-CSB1 is based on an ESP32 microcontroller, so in order to configure the EX-CSB1 using the Arduino IDE, we need to add support for the ESP32. We do this by adding an internet web address to the Arduino IDE's settings or preferences. I'll include the address in this video's description, but I'll also show you how to find it on the DCC-EX website. First, from the DCC-EX homepage, expand the EX Command Station menu item in the left-hand sidebar menu. Then expand the entry for DIY Advanced Options, and then under that, expand the entry for Microcontroller Boards. Then we'll click the entry that says ESP32 Recommended. Then we'll scroll to the very bottom of the web page that appears to where it says Adding ESP32 support to the Arduino IDE. There, we'll click the link to the official Espressif guide. Finally, on the Espressif docs page, we'll copy the link near the top of the page where it says Installing using Arduino IDE. We can choose the Stable Release link. No need to live dangerously here. If we hover our mouse over the link, a copy icon button will appear at the right. We can click this button to copy the link to our computer's clipboard. We can then exit our web browser. Now we'll launch the Arduino IDE we previously downloaded. We can find it in our Mac's application folder. Windows users can find a shortcut to the IDE on our Windows desktop. The first time we launch the IDE, our computer will ask us if we're sure we want to open it. We'll say yes. Now, to add ESP32 support to the Arduino IDE, we'll open the IDE's Preferences window by selecting Settings from the Arduino IDE menu on a Mac or Preferences on a PC. At the bottom of the Preferences window, we'll look for the box that says Additional Boards Manager URLs. We'll click the button to the right of this box and paste the URL we copied from the Espressif docs page. Then we'll click OK to close the Boards Manager window and OK again to close the Preferences window. Then we'll open the Arduino Boards Manager by clicking on the icon at the left just below the folder icon that looks like the outline of an Arduino Uno. In the text box at the top where it says Filter Your Search, we'll type ESP32. Then we'll look for the entry that says ESP32 by Espressif Systems. Now we need to select the correct version to install. At the time of the making of this video, DCC-EX is only compatible with version 2.0.17 or possibly older of the ESP32 board package, so we'll need to select version 2.0.17 from the drop-down menu. Then we can click Install. We should see some messages from the Arduino IDE as it installs the new board package, with a success message when it is done. Note that because we have installed an older version of the ESP32 board package, from now on, every time we launch the Arduino IDE, it will ask us if we want to update our board packages. We do not want to update the ESP32 board package, so we need to click Later. We can now quit the Arduino IDE. Download or copy DCC-EX EX Command Station. Now let's get a copy of the DCC-EX EX Command Station software. We can either download a fresh copy from the DCC-EX GitHub page or make a copy of the Command Station EX folder that EX Installer created for us in the last video. If we simply want to customize a version of the EX Command Station software that we already have on our Command Station, then the easiest thing to do is to make a copy of our current Command Station EX folder. If we used the EX Installer to install EX Command Station, as shown in my last video, We will find that folder inside the EX installer folder in our home user folder. We can make a copy of the folder and place it on our desktop. If we want to use a fresh copy of the EX Command Station software or update to a newer version, we can download a copy from the DCC-EX GitHub page. We'll go to the DCC-EX homepage in our web browser and click on the Prod button in the EX Command Station Releases box at the top right of the page. We will use the EX Command Station GitHub link lower down on the page where it says EX Command Station Repository. Note that at the time of this video, DCC-EX had not updated its official release page with a version of DCC-EX that supports the EX-CSB1, as they have been more focused on using GitHub functionality to support the EX installer. So we'll click on the EX Command Station GitHub link. Then, on the DCC-EX GitHub page, we'll click the green Code button and select Download Zip from the menu. This will download the EX Command Station software to our Downloads folder. We can now quit our web browser. In our Downloads folder, we'll double-click to open the zip file we just downloaded, and we should see the Command Station EX Master folder appear. We can drag this folder to our desktop. We then need to rename the folder to be just Command Station EX. Now, whether we copied the folder from EX Installer or downloaded it from GitHub, we should have a Command Station EX folder on our desktop. Now we'll go to our Documents folder and look to see if there is an Arduino folder already there. If not, we'll create one. Then we can drag the Command Station EX folder from our desktop into the Arduino folder in our Documents folder. Note that if we have previously used the Arduino IDE to install DCC-EX, there may already be another version of EX Command Station in the Arduino Documents folder. If so, we'll need to rename that other older version to something else so that we can copy in our new folder. The last thing we want to do before we open EX Command Station in the Arduino IDE is copy over any of our existing configuration files into the new Command Station EX folder we just created. If we previously used EX Installer and saved our configuration files in a My EX Installer folder or other location, as I described in my last video, we'll find the configuration files there. We can copy these configuration files into the Command Station EX folder in the Arduino folder in our Documents folder. If we don't have or don't want to use any existing configuration files, then we'll need to create a config.h sketch in order to use the Arduino IDE with the EX-CSB1. The default config.example.h sketch won't work. So if we don't have a config.h sketch, we'll copy or duplicate the config.example.h sketch and rename it config.h. We'll edit it to work with the EX-CSB1 in a moment in the Arduino IDE. Upload EX Command Station to the EX-CSB1. Now we need to connect our DCC-EX EX-CSB1 command station to our computer using a USB cable. As I mentioned in the last video, we need to make sure we use a USB-C data cable, not just a charging cable. We'll also want to make sure we plug it into a USB port on our computer rather than a hub until we know it works. Then we can open the Command Station EX.ino sketch in the Arduino IDE by double-clicking its icon in the Command Station EX folder. If we did not copy our own config.h sketch to the Command Station EX folder and instead made a copy of the config.example.h file, we'll need to edit the new config.h sketch to work with the EX-CSB1. We can navigate to this sketch using the three dots menu in the upper right corner of the IDE window. The Arduino IDE sorts capital letters before lowercase letters, so the config.h sketch will be listed near the bottom of the window. There are three things we need to configure: the motor shield, the OLED display, and our Wi-Fi settings. So we'll scroll down to around line 59 in the config.h sketch where it says #define motor shield type and change the standard motor shield to EX-CSB1. Then we'll scroll down a little further to line 110 or thereabouts, where it says #define Wi-Fi SSID, and change the your network name to the name of our home Wi-Fi network. We need to make sure that we put the name in quotes. Then we replace the your network password a few lines lower down with our Wi-Fi network password, again in quotes. Finally, we scroll down to about line 163 and add the definition for the EX-CSB1's OLED display. We do this by typing #define OLED_driver 132, 64. There are no quotes, and we need to make sure that OLED_driver is all in capital letters. Now we need to select the COM port that the EX-CSB1 is connected to, set the board to be the ESP32 dev module, and set the communication speed. There are a couple of different ways to do this, depending on whether we have previously configured our DCC-EX command station in the Arduino IDE. We can use the drop-down menu in the top left corner of the IDE window to either select the port the EX-CSB1 is connected to from the list, or choose Select Other Board and Port from the bottom of the menu. We can also click on one of the pencil icons in the menu to accomplish the same thing. Then, in the dialog box that appears, we need to make sure that the port the EX-CSB1 is connected to is selected. Again, as we discussed in the last video, if there is more than one port listed and we are not sure which one the EX-CSB1 is connected to, we can unplug the EX-CSB1 from our computer, note which ports are still listed, then plug the EX-CSB1 back in and see which new port appears. Then, in the board's search box, we'll type ESP32 dev mod. We want the one at the top of the list that just says ESP32 dev module without any extra qualifiers. So we'll click on that entry in the list so it has a check mark next to it, and then click the OK button at the bottom of the window. Note that we can also set the port and the board from the Tools menu in the menu bar. Now, we need to set the communication speed. We'll also do this from the Tools menu. We need to scroll down to near the bottom of the Tools menu and set the upload speed to be 115/200. Now we can verify that we have the correct port selected by opening the Arduino IDE serial monitor. To do this, we click the icon in the top right corner of the window that looks like a small magnifying glass. We'll verify that the serial monitor's communication speed is also set correctly by checking the drop-down menu at the far right side of the serial monitor window to make sure that the baud rate is also set to 115/200 and change it if not. Now we can verify that the Arduino IDE is connected to the EX-CSB1 by typing open angle brackets =, close angle brackets in the serial monitor's message box and then pressing return. We should see a response on the display that track A is configured as the main track and track B is configured as the programming track, unless for some reason you've changed it. Now we can verify our code to make sure that there are no errors. We do this by clicking the small round button with the check mark in the upper left corner of the IDE window. We'll see a message at the bottom of the screen that the IDE is compiling our sketch. If the IDE compiles the sketch without any errors, we can upload it to the EX-CSB1 command station. To upload our sketch to the command station, we'll click on the small round button with the arrow just to the right of the Verify button with the check mark. This will again compile our code and upload it to the EX-CSB1. We'll see the progress of the upload in the output window below. If for some reason the upload doesn't start, double check to make sure that the correct port is selected and the upload speed is set to 115/200. When the upload is complete, the EX-CSB1 will reboot. We should see the new version of our EX command station software indicated on the OLED display, along with the IP address assigned by our home Wi-Fi network router. We have now used the Arduino IDE to configure our DCC-EX EX-CSB1 command station. Customize EX command station in the Arduino IDE. Now, let's look at an example how we can use the Arduino IDE to customize the EX Command Station sketch. This is one of the wonderful things about open source software. We can customize it to suit our needs. The model railroading community was instrumental in securing the rights of open source developers to create projects such as DCC-EX and JMRI. If you haven't already, be sure to watch my video number 5A, An Introduction to JMRI. If it wasn't for Bob Jacobson and his fight to keep JMRI free, DCC-EX as we know it might not exist today. So let's celebrate those rights and customize some code. On DCC-EX command stations based on the Arduino Mega, the EX command station software displays both the IP address and Wi-Fi port number we need to connect our Y-throttle and engine driver apps to DCC-EX to run our trains. However, on ESP32-based command stations, such as the EX-CSB1, EX command station displays only the IP address, not the port number. Even though the port number will almost certainly always be 2560, someone who has never used a DCC-EX command station, Y-throttle, or the engine driver app probably wouldn't know that. If we add that information to the display on our EX-CSB1, then anyone we invite over to run trains with us can get all the information they need to connect to the EX-CSB1 right from its display. We can find the code we need to copy in the Wi-Fi interface.cpp sketch. We'll select that sketch in the three dots menu. Then we'll scroll down to around line 374 and look for the line that starts with LCD open parenthesis 5, F open parenthesis double quote port. Let's select that entire line of text and copy it by pressing Command or Control-C. Now, we'll use the three dots menu again to go to the Wi-Fi ESP32.cpp sketch. We'll scroll down to line 220, just below the line that starts with LCD open parenthesis 7. This is the part of the sketch that runs when we connect DCC-EX to our home Wi-Fi network, which is called Station Mode. You can learn all about Station Mode and its alternative, Access Point Mode, in my video number 4D, Configuring DCC-EX Wi-Fi. We'll click at the beginning of line 220, then press Enter or Return to insert a blank line. We can then paste the LCD5 port code we copied from the Wi-Fi interface.cpp sketch. We also want to change the 5 after LCD parenthesis to a 7. When we're done, we need to make sure it looks exactly like this, with the capital and lowercase letters as shown and a semicolon at the end of the line. Now, on line 219 above, we need to change the 7 after LCD open parenthesis to a 6. Now, when we are in station mode, DCC-EX will display the IP address on line 6 of the display and the port number on line 7. Now let's scroll down to around line 273 to the part of the sketch that runs in access point mode. We'll again press Enter or Return to insert a blank line after the line that prints the IP address and paste the port code we copied earlier. We'll again change the 5 to a 7. Then on the previous line, we'll change the 7 to a 6. Then 2 lines up from that, we'll change the 6 to a 5. And 2 more lines up, we'll change the 5 to a 4. Now, when we are in access point mode, DCC-EX will display its Wi-Fi address on line 4 of the display, the Wi-Fi password on line 5, the IP address on line 6 of the display, and the port number on line 7. When we're done, we can upload our new code to the EX-CSB1 command station. We have now created our own custom version of EX command station, and our EX-CSB1 will display on the OLED screen all the information we need to connect our Y-throttle and engine driver apps to DCC-EX. All aboard! We'll want to keep track of any changes we make to the EX command station software so we can make them again the next time we update to a newer version. And there are lots of other little tweaks that we can make to the EX command station code to change what information is shown on the display and even how we run our trains. But we're nearing the end of our shift, so we'll save that for next time. Right now, let's go run some trains.
Yeah, come on down to the VN, let's throw light over. Signal indication VN, thanks.
Part 4. DIY Alternatives to the DCC-EX EX-CSB1. Let's wrap up this series on DCC-EX in 2025 by looking at 2 DIY alternatives to the EX-CSB1 DCC-EX command station. This video is not for complete novices to the DCC-EX system. For this discussion, I will assume that you are already somewhat familiar with how to assemble and configure a DCC-EX command station using an Arduino or a compatible clone. If not, please see my video series number 4 on how to assemble and configure a DCC-EX command station. In fact, I highly recommend that you first assemble an Arduino-based DCC-EX command station and learn how DCC-EX works before moving on to these other DIY alternatives. The DCC-EX developers have 10 years of experience ironing out the kinks running DCC-EX on the Arduino, and as we will see, they are still navigating through some of the idiosyncrasies of these other boards. Plus, we can reuse many of the parts from our Arduino-based DCC-EX command station when we assemble a new command station using an ESP32 or STM Nucleo board. I will also refer you to some of the previous videos in this series on how to configure a DCC-EX command station, including video number 8B, Configure DCC-EX EX-CSB1 with EX Installer, and video number 8C, Configure DCC-EX EX-CSB1 with Arduino IDE. All of those lessons will be applicable to the boards we look at today, not just the EX-CSB1. Here are the stops on today's itinerary. First, we'll look at how to assemble an ESP32-based DCC-EX command station using an ESP-Duino WeMOS board, and then install and configure DCC-EX on the ESP32. Then we'll do the same thing for an STM Nucleo board. Notch up the throttle because we're highballing out. DIY alternatives to the DCC-EX EX-CSB1. Part 1. The ESP-Duino WeMOS D1 R32. The first option we will look at today is an ESP32 development board, commonly referred to as an ESP-Duino or sometimes a WeMOS D1 R32. These boards and their various clones use an ESP Room32 microcontroller with built-in Wi-Fi mounted on a board that looks like an Arduino Uno. In fact, the Room32 is the original version of the Room32E chip that DCC-EX is using on the EX-CSB1. And because the board has the same form factor as the Arduino Uno, we can easily attach an Arduino motor shield on top of the board to control our trains. We can find various copies and clones of these boards on Amazon and other merchant websites for less than $10, but be sure to check the delivery options as some of them are shipping from overseas. The original ESP-Duino versions had a USB Type-B connector on them, similar to the Arduino, while the WeMOS versions have a micro USB connector. I purchased a board on Amazon in 2024 from HiLetGo and received a WeMOS branded board. The other hardware item that we will need is a compatible motor shield. We can use either an Arduino R3 motor shield or a compatible clone, or an EX motor shield 8874. If you would like more information about the motor shields, please see my prior video number 4A, Assemble a DCC-EX command station. For this video, I will use the same Deke Robot Kubuk motor shield clone that I used in that video. We can find these on Amazon for about $15. Assemble an ESP32 DCC-EX command station. Once that we have the ESP32 board and the motor shield, we can assemble the command station. We'll start by mounting the motor shield onto the ESP-Duino WeMOS controller board. However, we need to make some slight modifications to the motor shield first, by bending 4 of the header pins on one side of the board. As I mentioned in video number 4A, The voltage we need on the motor shield to run our trains could damage the controller, so we need to prevent that voltage from reaching the controller. In that prior video, I cut a small trace on the backside of the board to do that, but in this video we're going to bend the header pin that carries that track voltage. This is the pin that is marked VIN on one end of the header with 8 pins. We just need to bend it enough so that it won't go into the header socket on the controller board. I like to bend the pins inwards so that I won't accidentally touch them later. In addition to the VIN pin, we also need to bend the A0 and A1 pins in the 6-pin analog pin header. We need to bend these because DCC-EX uses these pins for current sensing, but the ESP32 uses those circuits for its Wi-Fi. The A0 and A1 pins are the pins just across the gap between the headers closest to the VIN pin we just bent. Finally, we need to bend the I/O ref pin, which is the second to last pin on the header with the 8 pins that also has the VIN pin. The ESP-Arduino WeMOS controller boards send 5 volts through this pin, but the motor shield returns that voltage back to the controller via the analog pins, which would fry the ESP32 microcontroller, which runs on 3.3 volts. Once we have bent the 4 pins, we can carefully insert the rest of the pins into the header sockets on the controller board and gently press the motor shield into place. The bent pins will cause the motor shield to ride a little higher on that side, but that is okay. Just make sure the motor shield is snug in its sockets. Now we need to install 3 short jumper wires and a resistor into the header sockets on top of the motor shield. We can make our own jumper wires by cutting a short length of 22 gauge solid core wire about 1 inch or 25 millimeters long, and then stripping off about 3/8 of an inch or 9 millimeters from each end. Next, we'll bend the stripped wire into a square U shape. Then we place the stripped wires into the appropriate pin sockets on the header as follows. One jumper will go from the socket for the A0 pin we bent on the analog header to the socket above the A2 pin on the same header, while another will go from the socket above the A1 pin we bent to the socket for the A3 pin. We can bend the jumper wires a little bit side to side so that their insulated parts sit flush next to each other. Be sure there is no exposed bare metal wire touching. The last jumper wire will go from the socket above the I/O ref pin we bent on the 8-pin header to the socket for the 3.3 volt pin 2 spots over. This will help ensure that we don't fry the ESP32. Lastly, we need to install a small 200 to 300 ohm resistor between the socket for the 3.3 volt pin, where we just put one end of the third jumper, to the socket above the I/O0 pin at the end of the header. We can get a package of 100 suitable resistors on Amazon for about $5.50. Keep the other 99 for spares. We need to add the resistor because there is a defect in these ESP-Arduino WeMOS boards that prevents the Wi-Fi from working reliably unless we do this. In my own testing, I was able to use the Wi-Fi somewhat in access point mode, but could not use it at all in station mode until I added the resistor. As with the jumper wires we made, we will want to cut the resistor to about 1 inch or 25 millimeters long, with the resistor itself in the middle, and then bend it into a square U shape. One end will go into the same 3.3 volt socket as the last jumper wire. It may help to take the jumper wire back out of the socket and put the resistor in first, or put them in together. The other end will go into the socket above the I/O0 pin at the end of the header. Again, we can make sure the 2 items are snug flush against each other, but make sure that no bare metal wires are touching that shouldn't be. We have now completed the basic assembly of the ESP32 controller board and the Arduino motor shield clone. Note that if we want to use an EX motor shield 8874 with the ESP32 controller instead of an Arduino-style motor shield, we will need to follow a different set of steps to prepare the motor shield. We can find those instructions on the DCC-EX website, and I'll include a link in this video's description. In addition to the ESP32 board and the motor shield, we will also need a suitable power supply, USB cable, and wiring to power our DCC-EX command station and connect it to the tracks on our layout. Again, see my video number 4A for detailed information and instructions on the necessary parts and how to assemble them. Also, see my video short on using ferrules with stranded wire to make the connections easier. We don't need to add a separate Wi-Fi shield to the ESP32 command station because the ESP32 already includes built-in Wi-Fi. However, we can attach one or more OLED displays to the I2C pins on the motor shield the way that I described in the two previous videos in this series. Number 8E, add a second display to our DCC-EX command station, and number 8F, add a display to DCC-EX using an I2C multiplexer. Now that we have assembled the ESP32 command station hardware, we are ready to install and configure DCC-EX. Install and configure DCC-EX on the ESP32 command station. We are now ready to install and configure DCC-EX EX command station on our ESP32 controller board. Fortunately, for those who have been following along with this series, we configured DCC-EX on the ESP32 exactly the same way that we did on the EX-CSB1 in earlier videos. We can use either the DCC-EX EX installer or the Arduino IDE. I am not going to repeat all the steps for installing EX installer and the Arduino IDE in this video. Please see video number 8B, Configure DCC-EX EX-CSB1 with EX installer, and video number 8C, Configure DCC-EX EX-CSB1 with Arduino IDE for detailed instructions on how to install and use those tools. For the purpose of this video, there are only a few settings that we need to change to configure EX command station on our ESP32 controller board. We'll look at EX installer first. Using EX installer. After we connect our ESP32 controller board to our computer using an appropriate USB cable, we'll start EX installer and make sure that Expressive ESP32 is enabled in the Enable Extra Platforms box. Then we'll forward to the Select Your Device screen. We'll click the radio button for the USB port our ESP32 is connected to. If we're not sure which port that is, we can unplug the USB cable, press Refresh Device List, and see which port disappears. Then plug the cable back in and refresh again to see the port that shows up. Then, in the drop-down menu for that port, we'll select ESP32 Dev Kit as the device. We then proceed to select EX Command Station as the product to install and decide whether to create a new configuration or use an existing configuration that includes our EX-Rail automations and our myhal.cpp sketch. After that, we select all the options for our command station's configuration, including its display settings, Wi-Fi, and other options. The most important thing we need to select is the type of motor shield or motor driver. For this video, we'll select Standard Motor Shield, but if we were using the EX Motor Shield 8874, we would select that option instead. If we select the Advanced Config option, then we will have a chance to review the config.h file that EX installer makes for us. It can be handy to keep a copy of this information for future reference. Then we can compile and then load the EX Command Station software to our ESP32 microcontroller. When the code is done loading, the command station will reboot, and we can verify that DCC-EX is running correctly in the device monitor window. Using the Arduino IDE. If we would like to make additional edits to the EX command station code, we can use the Arduino IDE to install the software on our ESP32. We do this in the exact same way that we did in video number 8C. All the steps are the same. We need to add the URL for the ESP32 board packages in the Setting Preferences window, make sure that version 2.0.17 of the ESP32 board package is installed, select the USB port the ESP32 controller board is connected to, and make sure the upload speed and serial monitor baud rate are both set to 115200. We then need to copy or create a config.h file. We can use the config.example.h file as a template, or copy the config.h file the EX installer created. We'll want to make sure that the motor shield type is set to Standard Motor Shield or EX8874 Shield if we are using the EX Motor Shield 8874. We configure the settings for our Wi-Fi and display the same way we would on any DCC-EX command station. We don't need to tell EX command station that we are using an ESP32. It will figure that out by itself. We then upload the code to the command station just as before by using the round button in the upper left corner of the IDE window. That's all there is to it. We have now assembled an ESP32-based DCC-EX command station for less than $50 and are ready to run some trains. Grab some iron because we're a ball of fire. Part 2. The STM Nucleo 64 F446RE. The second alternative we will look at today is assembling a DCC-EX command station using an STM32 Nucleo board from ST Microelectronics. ST, or ST Micro, is a large European multinational semiconductor manufacturing and design company. Ironically, one of the companies that eventually merged to form ST Micro was the Italian semiconductor company SGS, founded by Adriano Olivetti in the 1950s. As I described in my video number 4X, DCC-EX series bonus materials, the Olivetti company was one of the co-founders of the Interaction Design Institute Ivrea, where the Arduino project was first conceived 20 years ago in 2005. Now we'll look at using an STM 32-bit microcontroller to use in place of the 8-bit ATmega microcontroller in the Arduino. The specific board that we will use is the STM Nucleo 64 F446RE. This is one of several STM boards that DCC-EX supports. Like other Nucleo boards, it features a set of header pin sockets that are compatible with Arduino-style shields, which means that we can easily mount an Arduino motor shield to the board. The Nucleo 64 and the larger Nucleo 144 boards also feature a second set of header pins called Morpho pins that allow for additional I/O connections to the board. As a result, the board offers a lot of physical connectivity options. Also, the digital pins on the board are 5-volt tolerant, which means that we can use many of our 5-volt Arduino accessories with them, including sensors and I2C devices. Note, however, that the analog pins are not 5-volt tolerant and are limited to a maximum of 3.3 volts. The STM Nucleo 64 boards also don't need any hardware modifications to use, unlike the ESP-Duino that we looked at earlier. Also, when we update the code to the boards, it generally uploads much faster than on the ESP32. However, there are some downsides or drawbacks to the STM Nucleo. For starters, the boards cost about $20 more than the ESP32 boards we looked at, or about $30 for the F446RE. Also, the STM Nucleo 64 boards don't include built-in Wi-Fi, which means we will have to add a Wi-Fi shield to the board, the same that we did with our Arduino-based command station in video number 4C, adding a Wi-Fi shield to our DCC-EX command station. Unfortunately, the Wi-Fi shield with the correct firmware for DCC-EX is currently unavailable in the US because the DCC-EX hardware store is temporarily closed. However, we can order the correct version direct from the manufacturer Maker Fabs, as well as some other online retailers, although it may take a bit longer to arrive. Nevertheless, this will add an additional $10 plus delivery fees to the cost of our command station, and the assembled command station will be larger in physical size than the ESP32 command station. Finally, before we use the STM Nucleo, Windows users will need to install a device driver, and we should update the board's USB firmware. Assemble an STM Nucleo DCC-EX command station. For this video, we will pair the STM Nucleo board with an EX Motor Shield 8874. This motor shield provides higher current to the track than the standard Arduino motor shield and served as the inspiration for the EX-CSB1. The EX Motor Shield 8874 also features a regulated power supply so that we can safely power the Nucleo board from our track power supply if we choose, and we don't need to make any modifications to the board to use it. We could use an Arduino R3 motor shield, but the Nucleo F446RE is only rated for a maximum of 12 volts on the VIN pin and really prefers 7, so we would need to power the Nucleo separately if we want to run our trains using a power supply with more than about 9 volts. Again, the EX Motor Shield 8874 is currently unavailable in the US, but we can order one from the manufacturer Semify in Austria or another international retailer. The Nucleo F446RE includes a jumper on the board that we can use to select whether it uses the USB connector or the VIN connection to the motor shield as its power source. We will need to set the jumper to the USB connection in order to program the board, but once that is done, we can set the jumper to power the Nucleo from the EX motor shield 8874 instead if we like. We'll start our assembly by pressing the motor shield's pins into the Arduino header sockets on the Nucleo board. As always, we'll want to make sure that everything is lined up and all the pins are going into the sockets. We'll also need to be careful not to stab ourselves with or otherwise damage the morpho pins. Long term, we will want to have something to place the Nucleo board on so we don't short out any of those pins. Next, we'll add the Wi-Fi shield to the top of the motor shield. We'll need to remove or relocate the jumpers on the transmit and receive pins on the top of the Wi-Fi shield. Again, see my video number 4C if you would like more detailed information. We'll use two female-to-female jumper wires to connect the Wi-Fi shield to two of the morpho pins on the Nucleo board. We can start by pressing one end of each jumper wire onto a pair of the transmit and receive pins on the Wi-Fi shield. We can then wrap the wires under the board to keep them out of the way. We'll connect the other ends to the Nucleo in a moment. Now we attach the Wi-Fi shield to the motor shield. Again, we'll want to make sure that everything is lined up and all the pins are in the correct sockets. Next, we'll attach the two jumper wires from the Wi-Fi shield to the first two morpho pins. These are the pins closest to the barrel connector for the power supply on the motor shield. The wire from the receive pin on the Wi-Fi shield will attach to the number 1 pin closest to the edge of the Nucleo board, while the wire from the transmit pin on the Wi-Fi shield will attach to the number 2 pin next to the number 1 pin. We can then attach our I2C devices to the I2C pins on the motor shield in the standard fashion. Note that although I2C on the Nucleo is 5-volt tolerant, the EX motor shield 8874 only supplies 3.3 volts to its VCC pin. Therefore, if we want to use a 5-volt accessory such as an LCD display, we will want to get the 5 volts VCC directly from the Nucleo. We can get this from morpho pin number 18. To find this pin, we'll count 7 pins back from the Wi-Fi transmit wire we attached to the number 2 pin, then connect the VCC to the 8th pin. There will be 7 unused pins between the number 2 pin and the number 18 pin when we are done. We have now assembled a DCC-EX command station using an STM Nucleo board. Once we add a power supply and prepare some track feeder wires, we will be done with the basic hardware setup. Now we are ready to install and configure DCC-EX. Install and configure DCC-EX on the STM Nucleo command station. In order to install DCC-EX on our STM Nucleo, we first need to connect it to our computer. Unlike the Arduino or the ESP32, the STM Nucleo mounts on our computer just like an external drive. On a Mac, we don't need to do anything, and the F446RE will simply show up on our desktop with a drive icon. On Windows, however, we will need to install a driver before we can connect the Nucleo to our computer. We can download the driver directly from DCC-EX using a link on their website. I'll include the link in this video's description. This will download a zip file to our computer. After the computer completes the download, we'll need to extract all the contents of the zip file. This will create an STmicro Nucleo drivers folder on our computer. Then we navigate in the Nucleo drivers folder to the folder that ends in 009 and find the batch file called ST-Link Win USB install. We'll right-click on this file and select Run as Administrator from the pop-up menu. This will launch the device driver installation wizard. If it asks whether we want to allow it to make changes, we need to say yes. We'll click Next and then Install. When it's done, we'll click Finish. We can now connect the STM Nucleo to our computer with a USB cable. Unfortunately, the F446RE uses a USB mini connector, which is that awkward size that was popular 10 years ago for about 5 minutes before it got replaced by micro USB. We'll need to provide our own cable, so hopefully you have one somewhere in a drawer. When we connect the Nucleo to our computer, we will either see its icon appear on our desktop on a Mac or see a notification that it is mounted on our Windows computer. Next, we will update the firmware for the Nucleo's USB serial communications controller. While not absolutely essential, updating the firmware will eliminate a bug that sometimes causes the USB serial connection to fail when using JMRI or the EX Web Throttle app with our DCC-EX command station. We can find the firmware update in the Nucleo drivers folder in the 007 folder. Inside this, we'll open another 007 folder and then the Windows folder. We then launch the ST-Link Upgrade application. In the application, we'll click the Device Connect button and our computer will connect to the Nucleo. Once it does, we'll see the current firmware version on the screen. We can click the Yes button to update the firmware. After a minute or so, we should see a message that says, Upgrade is successful. We can close out of the firmware updater. There is also a Java app for Mac and Linux users to update the firmware, but it requires an Intel x86 version of the Java runtime environment. And while it is possible to run the x86 JRE on an M-series Mac, frankly, it doesn't seem to be worth the trouble. I'll leave a link to another video on YouTube that explains how to do it, if anyone is a glutton for that particular kind of punishment. We can now install the DCC-EX EX command station software on the STM Nucleo. As with the ESP32 command station we looked at earlier, we can use either the EX installer or the Arduino IDE to install EX command station on the STM Nucleo 64 F446RE. Using EX installer. In the EX installer, we'll make sure that the ST Microelectronics Nucleo STM32 slider is checked in the Enable Extra Platforms box on the Manage the Arduino CLI screen. After that, using EX installer is exactly the same as we have already done. The only difference is that we choose the option for the ST Microelectronics Nucleo F446RE from the drop-down menu on the Select Your Device screen, and then select the appropriate display and motor driver on the configuration screen. So for this video, we'll select a 20x4 LCD display and the EX-8874 shield for the motor driver. After that, we upload like before, and we're done. Using the Arduino IDE. We can also use the Arduino IDE to upload DCC-EX EX command station to the STM Nucleo. First, we need to add a URL to the Additional Boards Manager URLs box in the Settings Preferences window, the same way that we added a URL for the ESP32 in video number 8C. We can obtain the URL from the DCC-EX website, and I will include it in this video's description. Once we add the URL in the Settings Preferences window, we can use the Arduino Boards Manager to add version 2.7.1 of the STM32 board package to the Arduino. We need to make sure that we choose version 2.7.1 and not a newer version. Then we select the USB port that the Nucleo is connected to, enter Nucleo in the board's search box, and select Nucleo 64 from the listed options. Then we need to go to the Tools menu and scroll down to where it says Board Part Number. This will open a flyout menu to the side where we can select our F446RE board number. Finally, we can make sure that the USB speed in the Tools menu is set to Low Full and confirm that the baud rate in the serial monitor is set to 115/200 baud. As before, we make sure that the motor driver, Wi-Fi, and display settings in our config.h file are accurate. Because we're using the EX Motor Shield 8874 for this video, we'll set the motor shield type to EX8874 Shield. Then we compile and upload the code. We have now assembled and configured a DCC-EX command station based on an STM32 Nucleo board and an EX Motor Shield 8874 as a second alternative to the EX-CSB1. All aboard! What's next? Supercut Part 2 and assembling a YT controller. In Part 2 of the Supercut, we'll look at how to add 1, 2, or even more displays to our DCC-EX command station, and add new functions to the command station using the myhal.cpp sketch. After that, we'll look at how to assemble a YT controller to use with DCC-EX to control our trains. Be sure to subscribe to the channel so you won't miss any upcoming videos. And check this video's description for links to my other videos, including my video series on assembling a DCC-EX command station and my series on using JMRI's Decoder Pro app to control our trains. The year is half over, but that means the second half is just beginning. There's places to go and things to see, so hop on board and let's find out together what lies on the tracks ahead. Until then, thanks for watching. Well, Scratchy, are you ready for our next run? Then let's go find our train. All aboard!